So we've learned how to write linear equations and write linear functions and how to graph linear functions, and now we're going to apply it. And we're going to do some story problems with linear functions. So 15 days after Alan began a diet, he weighed 176. After 45 days, he weighed 170. Remember why X and Y, how X and Y work. Like X is your independent variable, and then the Y depends on the X. So in this situation, I believe it's saying that his X is the time on the diet, and then his weight is kind of dependent on how much time he's on the diet, right? So 2 points on the graph would be 15, 176, and 45, 170. How do I write the equation of the line? Well, what do I need? Right, I need the slope. So 6 out of negative 30, so negative 1/5. Why does it make sense that the slope is negative? Right, he's losing weight. As time goes on, he's weighing less and less, so he's losing the weight. So if the y equals negative 1/5 x plus b, if I pick a ordered pair, maybe the 15, so 176, negative 1/5 of 15 is negative 3 plus b, so the b is 179. So my function, and I'm writing it in function notation, negative 1/5 x plus 179. How much did he weigh at the beginning of his diet? Well, at the very beginning, how many days has he been on the diet? Right, 0. So after 0 days, he weighed 179 pounds at the very beginning. How much did he weigh after 60 days? Right, we evaluate 60. So what is that? Negative 12, so 12, so is that 167? Now, here's an interesting one. When will he weigh 165? Now I'm not plugging in for the x anymore. What am I plugging in for? Right, I'm plugging in for the y and solving for x. So if I subtract that from both sides, negative 14 is negative 1/5 x, and if I multiply both sides by negative 5, it looks like 70 days. Notice that I have my labels like days and pounds and how important those were. And obviously we know that this is not truly a true situation, right? We don't lose weight in a linear fashion. It's a made-up story problem, right? But yes, that's it. One more example. This is about life expectancy, which is, again, not linear. But it's saying in 1950, life expectancy was 65 years. And I defined the x for you as the number of years since 1950. So in 1950, the x would be 0. The y is the life expectancy for that year. 20 years later, in 1970, it's 67 years. If I write the equation of the line, I'm kind of happy because I know the b already. I don't even have to calculate it. I just need to calculate the m. So 2 over 20, or 1/10, is the m. And I already know that the b is 65, so f of x equals 1/10 plus 65. Why does it make sense that the life expectancy slope is positive? Because you're right, the life expectancy is going up. Using this, what will the life expectancy be in 2000? How many years after 1950? That's 50 years later. So you're evaluating f of 50. So 1/10 times 50 is 5 plus 65 is 70 years. When will the life expectancy be 72? So now you're plugging in for y, 1/10 x plus 65. So if I subtract from both sides, I get 1/10 is 70, or 1/10 is 7. So this is in 70 years. What's 70 years from 1950? 2020, look at that, 2020. Story problems using linear functions.